In this video, I am going to tell you about the concept of fundamental theorem of arithmetic, what it means, and an example to pinpoint what are the aspects of this theorem. Fundamental theorem of arithmetic says that every composite number, now we all understand what is a composite number, okay, can be factorized, which means what? Its factor can be written down as a unique product of primes. What does this mean? This means that whenever we want to express a composite number in terms of its factor, those factors which are available is a unique combination for every composite number. Okay, it cannot be the same for two composite number, except for the order in which prime occurs. Let me explain this to you through an example. Let's say we have a composite number 468. Okay, and I want to write down this as a product of its prime, and I will take two cases which I will take in the next slide by building a tree for prime factorization. So let's say I have 468 and I divide this by 2. Okay, what will I get? I will get 234. I again divide this by 2. I would get 117. Right? Now I divide this by 3. I get 39. I again divide this by 3. I get 13. And then I divide this by 13. Okay, I get 1. Or in other words, I can also write 468 as 2 times 2 times 3 times 3 times 13. Or simply 2 square into 3 square into 13. Should we just put down these values in the first equation that we saw? So we will have 468 as 2 square into 3 square into 13. Right? Now let me do the prime factorization of 468 again, and probably I'll do it in a different manner this time around. So this time what I do is I write 468 and I divide this by 13. So I get 3, 6. Right? That's what you'll get when you do the division. Now I divide this by 3 and I get 12. I again divide this by 3. I get 4. Divide by 2, I get 2. I divided by 2, I get 1. So this time again 468 can be written as 13 times 3 square times 2 square. Right? 13 times 3 square times 2 square. Let's put this value in the original equation that we had. 13 times 3 square times 2 square. Now if you notice, in both these situations we have 13 over here, you have 13 over here, we have 3 square over here, you have 3 square over here, you have 2 square over here, you have 2 square over here. Now let's see the equation. The equation says that for every composite number, which is 468 in our example, can be factorized, means what? Can be written down as a product of its prime numbers as a unique product of primes. So this combination, complete combinations, if you see, is unique. The elements of this combination are same, right? Except for the order in which the prime occurs. What does it mean? Here you had starting 13, here you had 13 towards the end. 3 square incidentally happens to be in the middle in both the cases, 2 square in the beginning, 2 square in the end. So the order might differ, right? The order of occurrence of prime might differ, but the output, okay, which is the combination of prime that we have is unique for every composite number. You cannot have any other composite number having the same factorization as 468, or for that matter, for any other number. And this is what fundamental theorem of arithmetic is all about.